back. In this video, I'll be talking about chatter. Now, chatter is important because throughout in this section and the early part of section 2, I'll be talking about a chatter application in ROS, and it is very important to understand what chatter actually means because the things might seem easy, but having an overall general context about chatter is very important. So let's get started. So chatting, the word chatter comes from internet-based chat in and during the internet boom, applications such as this were created in which people used to chat with each other. In my days in college, chatting used to be the in thing stuff in the campus 20 years ago. But now you can map this to something like a Facebook Messenger or Instagram Messenger. Okay, so that's where the root of the word chatter comes, in which you talk to one person and the other person replies. So essentially, chatter is also used as a basic application to test a particular product. Example, in the world of Java, you have socket programming, in which you can go and create your basic chat kind of a console. So robotics and ROS takes that example of a chatter in which there is a concept of talker, listener, and topic. Now, these things will keep on coming in the videos next, and I thought that in this video, I would give you a generic example from our common life. And once you get a hang of that, maybe it will give you an overview in the world of robotics. Okay. Now, first thing first. So, what is a talker? Talker, if you take the example of YouTube, a person who has launched his YouTube company or a company which has launched their YouTube channel is a talker because he or she or that company wants to go and take their message and mantras to the whole world. Okay, so they are like humans who want to go and speak out, saying that listen to me. All right. And similarly, the opposite party of talker is the listener. Folks like me and you, individuals who go and subscribe. Even company can subscribe to another YouTube channel from another company. Okay, so for example, here as you can see is the YouTube channel from my robot. Okay, so you can go and subscribe, shout out. All right. So that is if you try to map it to the world of YouTube, you understand now what is a talker and what is a listener. So talker is the publisher, which is the individual who is the YouTuber, and listener are guys like me and you. Then what is the topic? Topic is actually the channel, that platform. In this case, that particular YouTube channel in which you are subscribing. That becomes. So this one becomes your topic, the platform in which you are interacting. You can take it to the chat example also, in which one people is talking, one people is listening, and the platform or the topic becomes the chat software itself. All right. So let's move forward to the next concept of publishers and subscriber. It comes from the same analogy. So this will also keep on repeating, and this same diagram you will see in the being mapped to an robotics example in the next lesson. So it's good to kind of prep all of you up in terms of what is coming. Now in the world of ROS, we have something called as ROS core, which is the essential services or the heartbeat function, as we call in the world of software. So this is ROS core. So whenever you start ROS, you should have the ROS core initiated. No ROS core, no robotics in ROS. Simple as that. So that is the mother function which has to run in a particular window. So once that is running, you can create your publisher who wants to go and talk to the world. So once you create your publisher, this publisher has to be registered with the mother, which is the ROS core, because it has to register itself as an entity. Like a YouTuber has to register their channel in YouTube and follow the core principles and ethos which are laid down from YouTube. And then you also have a subscriber, like if you are an individual who does not want to create content but want to see contents, absorb content as an individual, then also you have to create a YouTube account. And then again, the rule is same, that you have to register with the mother, which is the ROS core in this case. and then whatever information exchange happens, which is the content in YouTube, is actually through the topic. Okay, so this is the architecture, high-end architecture, which I have told you in simple words, giving again, taking the example of YouTube and taking it forward. You will see the same example coming in robotics in the next lesson, in which I say, what happens if there is a camera, what happens if there is an ultrasonic sensor, so on and so forth. But try to get the core of it in simple language, in simple things. So that's the intention of this lesson. Now, you can say that, okay, no, this is some basic example. What about technology example? And I also want to tell you that this concept, as I was telling, is not something which is, exclusive to the world of robotics engineering. For example, if you take enterprise software, there is a product which is there called as Tipco. It's a middleware, and they have this publisher and subscriber model for stock trading, and it's a well established product. I'm sure that all of you know about RSS feed. Bloggers use this often. Internet works on RSS feed, and that also works on the concept of publishers and subscriber. If you are into Internet of Things and using Internet of Things, if you are doing IEEE protocols on IoT in your undergrad or your postgrad or just as a hobby, you must have come across MQTT, which is a protocol, and that also works for a publisher and subscriber kind of a model. The world is moving towards cloud computing, and cloud computing again uses concepts from publishers and subscriber. So what I would like to say that these concepts which I am talking about, the concept of publisher and subscriber is not exclusive to the world of robotics, but it is used in other aspects of technology and engineering and science as well. Okay. Now, there are certain key foundation principles for all publisher subscriber kind of model. Okay, and I reiterate that this is not just for ROS. Okay. Now, one thing is that the publisher and the subscriber should be independent of each other. Correct? There might be a very big YouTube channel which is in millions and millions of subscriber, but you do not like that genre. Maybe it's a music channel and you don't like that kind of music, so you can coexist without subscribing to that channel as an individual. And same with that channel also, right? That even if you don't subscribe, they are happy with whatever current user base. So there is independent existence of both the publisher and subscriber. That is the rule number one. Okay. The rule number two is that you don't need to know each other. I mean, you don't need to know. The publisher does not need to know what the subscriber is doing in detail, and vice versa. And that is again true for the YouTube application. Example, people who have subscribed to my YouTube channel, I do not need to know that, which part of the world they are from. I'm happy as they are subscribed to my channel. And vice versa, people who see my content, they are happy to see my content, and they actually do not care if I have recorded it in which part of the world. So we don't know each other's geographical locations. Okay, so they don't require to know each other, and geographical location is just one example. For example, if you take look at the technology part of it, a subscriber need not know the source code or the header files which are there in the publishers, and vice versa. One subscriber can, the third principle is that one subscriber can receive message from different publisher, and this is the example of YouTube also. You can subscribe to multiple YouTube channels. So this is common sense, and the publisher can send data to different subscriber. Okay, so your YouTube channel might have multiple subscribers. Example, in my channel, I don't have too many followers, but again a shout out, follow me out. I have close to 600 followers, and when I send a notification, all 600 of them get a notification. So you have to remember this four mantras when it comes to the foundation principles of the mantra when it comes to publishers and subscriber. And this will not only help you in robotics, it will also help you in other areas of technology, especially software engineering, web engineering, and cloud computing. All right. So let's see and let's turn the page and see another example of things like message, package, list, because this again will come up, and there also I'll be giving you example from the world of robotic. But now let's try to give you another example from simple life so that you are able to correlate with the lectures coming up. All right. So listen to me carefully. If this has been overwhelming, I would say that, you take a break, pause the video, have a glass of water or a coffee, and then come back. Okay, so ready? So let's get started. Now imagine this situation. Okay, so you have a beautiful university which you can see there, all right, and here is a student here who is enrolled in robotics engineering, for example. This particular gentleman, okay, is registered to the university. So when that person is registered to the university, so he would be sending a request for registration, as you can see, right? So if you mapped to the previous knowledge which you have got on publisher, subscriber, and talker. So this individual who is as an entity is called as a node, and this is your ROS core, right? Because that is the mother. The university behaves like a mother which holds students from various departments, various subjects, various elective. All right. So this becomes your core, isn't it? So let me write it down. This becomes a core, and if you come here, it becomes a node. Correct? Fair enough. Now, this person who is registered in this particular robotics course might be interested to write his blogs on a particular website and plays the role of a publisher. Possible, right? Probably he is writing his blogs on kinematics or Internet of Things or embedded systems and publishes a blog every fortnight. And then there is another student who is in probably say electronics engineering, finds his article very interesting, and this person is also registered to the core. Why? Because this person is also doing certain kind of course with this particular university. So this person also is another node. Okay, we might call this node 2 and we can call this node 1. Correct? And then she finds that this dude here writes good content, and she subscribes to his blog as a subscriber, and then there is a download happening of the content also, maybe a white paper or a PDF or a list of formula that node 1 has written, and node 2 goes subscribes first and then downloads it here. So these are the core concept which you need to know. So this is the core, this is the ROS core, node 1, node 2, and then there is the concept of ROS topic and ROS message. Now this one becomes your topic, and the actual content of the data becomes your message. All right. So I think we should pause for 5 seconds and think, what happened? And then once we have sat down for 5 minutes, I would say that you relook into this video and think about it. What I said, and try to map. What is core, what is node, what is a message and a topic, and move to the next video in which I'll be not be giving such examples which are from real life, hardcore concepts from robotics. Thank you, and I'll catch up with you in the next video.